Alright, so this is the review for the measures of center part of the statistics unit. Looking at number 1, we have a box plot here. Find the number of laps used to create the box plot, or explain why it's not possible to determine. So basically, we know that a box plot only shows us 5 values. So we can say it's not possible because we don't have all data. Part B, can the range be determined? The answer is yes, because for the range we just need the min and the max. We can see that the max is 14. We can see that the min is 4. So 14 take away 4 leaves us with 10. Can the mode be determined? That answer is no. I have no explain why it's not possible, because once again, we are not given the individual data to find the mode. Okay. All right. Number 2. Roger created a histogram for the pieces of candy in jars. Explain how to determine or why you cannot determine the number of pieces he used to create the histogram. So we can find it, and the way we'd find it is by adding the frequencies from each bin. So it doesn't ask us to do this, but we can look at it and say there's 1 plus 4 plus 3 plus 2, which gives us a total of 10 number of pieces of candy used to create the histogram. It has 10 pieces of candy, or 10 jars with pieces of candy. Okay. Explain how to determine or why you cannot determine the range. So we cannot see the highest and lowest values. We can get an idea of what the range might be, but we don't know the exact values, which we need. Can you determine the median of Roger's pieces of candy? If so, what is it? If you cannot, determine the narrowest interval. So we cannot see the median, but we know the median is at the 5th jar. So the 5th jar can be anywhere from, so if we look for the 5th jar from the right hand side, we have 1 plus 4, so the 5th jar could be in here. Or if we go from the right hand side, we have 2 plus another 3, so the 5th jar could be in here. So the closest range we can get is those 2 pieces right there. So the 5th jar can be between 21 and 60 pieces of candy. Moving on to the next page. Number 3, the box and whisker plot. So this is a double box plot, which has a greater median. So the women have a greater median. Remember, the median is that middle value right there inside the box, and it's greater by about 8 students. On average, are there more men or women in each psychology class? We're going to say women, and that's going to be because they have a larger Q1 and Q3. So we don't want to look at the spread, we just want to look at like where that middle set of data is. And they also have a larger median as well. Okay, which of the following is true about these 2 data sets? So the first thing you're going to do, which once again I'm not going to show this part, but you would use your calculator, create 2 lists, and then evaluate using the list the mean, the medians, the ranges, the means, and the variances. So if I call this list 1 and list 2, the medians for the 2 lists are 27.7 and 28, so those aren't the same. The ranges are 5 and 5, so those look like they're the same. The means are 12.4 and 27.7, so I had these medians wrong. I was looking at the wrong data. The medians were 12 and 28, still not the same. The means were not the same. And the variance, that was the mu, that was 1.59 and 1.67, so those were not the same. So the ranges were the only thing that were equal. Number 5, another double box plot. What is the range for each store? So the range is the difference between the highest and the lowest. So I have 80 minus 25, and I also have 80 minus 40. So that gives me 55 compared to 40. That's going to be A. Dillard's has a range of 55. Macy's has a range of 40. Number 6. The McDonald's 83rd and Indian School created a box plot representing the ages of their 20 employees. Create a dot plot that can represent their data. So a dot plot, first thing I want to do is look at the distribution. We know that there's 20 employees, and it looks like all these sections are the same size. So it looks like this should have some symmetric distribution. The thing that we can tell is the largest number is 28, the smallest is 16. So if I make a dot plot, 16, 28, the median is at 22. And if we know we want it to be symmetric, we probably want there to be more values here. And we just need everything to be symmetric around that with a total of 20 values. So I've already got 4, 5, 6. So then I'm going to add, let's see, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, maybe 17, 18, 19, 20. So that's a pretty symmetric distribution right there. And that'll do it for that one. Number 7, use the data set. So again, I'm going to put it into my calculator, identify a possible outlier. The only outlier that I see that could possibly be, well, so it could be either be a 10 or it could be 30. Remember, the outlier is we're looking for x less than q1 minus 1.5 times the interquartile range, or x is greater than q3 plus 1.5 times the interquartile range. So if I use my calculator, I'm going to come up with these values. The q1 is 12, q3 is 16.5, and that leaves the interquartile range at 4.5. So the test for outliers is going to be, is 10 less than 12 minus 1.5 times 4.5, which leaves me with 10 is less than 5.25, which that is not an outlier. And I'm also going to check, is 30 bigger than 16.5 plus 1.5 times 4.5. So 30 bigger than 23.25. That is an outlier, so we have one, and it is the 30. How does that outlier affect the mean? Well, since the outlier is larger, it's going to skew the mean to be larger. How does it affect the median? It doesn't. The median is the middle number. The middle number doesn't change regardless if there's an outlier. If it is an outlier, how does it affect the mode? It doesn't, once again, because the mode is the number that shows up the most. And if it's an outlier, how does it affect the standard deviation? It's going to skew the standard deviation larger. So the standard deviation is always going to get larger if there's an outlier because your numbers are more spread out. Remember, the standard deviation told us how spread out the numbers were. All right, number 8. Create a dot plot. So we're going to go through. We should have 3 5s, 3 6s, 3 7s, 3/8, 2 9s, 2 10s, 2 11s, and 2 12s. And the distribution is going to be skewed slightly to the right, where we talked about distribution. So remember that the distribution tells you it's determined by the tail, and there's a slight tail on the right, nothing significant. If you said it was approximately normal, that would also be acceptable. Okay. Number 9, the number of fans at a book signing is given below. Does there appear to be an outlier? I would say yes. It looks like 5 might be. So we're going to test for the outlier. So once again, we're going to put all that data into our computer. We're going to, or into our calculator. We're going to find Q1, which is 22. We're going to find Q3, which is 35, and we're going to find the interquartile range, which is going to be 13. And we're going to test, is 5 less than 22 minus 1.5 times 13. It turns out that 5 has to be less than 2.5, which is not true. So 5 is not an outlier. Okay? Does the outlier affect the mean? Well, there is no outlier. If there was, yes, it would affect the mean. It would skew it in whichever direction the outlier was on. So if 5 was an outlier, it would skew the data lower. Does the outlier affect the standard deviation? There is no outlier. But once again, if there was, 5 would make the spread larger. So it would skew the data. Okay. All right, next page. Number 10, last page. So we're surveying 2,500 students. The results show that 40% of the students under 16 prefer pizza, 10% 16 or older prefer hot lunch, and 7/10 of all students prefer pizza. Complete the two-way frequency table. So we're going to have to find 40% of 2,500. That's going to be under 16 for pizza. That is 1,000 students. 10% of 16 or older kids prefer hot lunch, so 10% of 2,500 is 250. And we know that 7/10 of all students prefer pizza. If there are 2,500 students, 7/10 of 2,500 is 1,750 students. Now we can fill in the rest. We know that this was 2,500. 16 or older, that's 750 more students. See, so there has to be 750 here because that has to add up to 2,500. Hot lunch, there should be 500. The total should be 1,500 and 1,000 to get us to the 2,500 total students. And the last question, number 11. The table shows the number of students participating in performing arts for a local school. What percent of juniors are in performing arts? So here's all my juniors in performing arts compared to, the only thing we can compare it to is the total number of students in performing arts, which is 458. So we're going to do 195 out of 458, which is 0.426, which is 42.6%. Part B, what percent of seniors are in theater? So we're looking at seniors in theater. So that's 33 out of all seniors, which is 263, which is going to be 0.125, which is 12.5%. Part C, write a proportion for the total number of students enrolled in chorus. So we have 217 students enrolled in chorus out of the 458 students. There's 217 out of 458. Write a proportion for the total number of seniors enrolled in dance. Seniors enrolled in dance is 167 out of, not 167. That's going to be 100 out of, how many total seniors are there? 263. So it's going to be 100 out of 263. And finally, part E, the proportion of seniors who prefer chorus is more than the proportion proportion of juniors that prefer chorus. So seniors who prefer chorus is, seniors in chorus is 130. That's 130 out of the 263 seniors total, which is 49.4%. And juniors are 87 out of the 195, which is 44.6%. So we're comparing them. Seniors have a larger percentage than juniors, so that answer is true. And that's going to do it for the measures of center review on the stats unit.